The speed of light is 300,000 kilometers per second, but do you know how freakishly precise that number is? The universe was born 13.7 billion years ago. Countless stars have exploded, countless black holes have devoured everything. Yet the speed of light has never changed, not even by 1 nanometer per second. That's insanely weird. It's like someone carved this number into the deepest layer of physical law at the very moment of the Big Bang. And scientists discovered in 2003 that if the speed of light were faster by just 1%, protons would fall apart. Slower by 1%, nuclear fusion inside stars could never ignite. The entire universe would instantly freeze into dead silence. In other words, the error margin for the speed of light is zero. Not close to zero, absolute zero. In 2012, CERN ran an experiment. They accelerated protons to 99.9999991% of the speed of light. To go just 0.0000001% faster would require enough energy to blow the entire Earth apart. Scientists did the math. To accelerate an apple to the speed of light would consume all of humanity's electricity output for an entire year. But the universe is ruthless. It sets the wall right here, lets you see it, but never lets you touch it. So the question is, why is this number so precise, so unchangeable? Is it really just a coincidence? The answer is more terrifying than you think. In 1905, a 26-year-old Einstein was working at the Swiss Patent Office. He was thinking about one question: what would I see if I rode on a beam of light? This seemingly simple question ended up tearing apart all of humanity's understanding of time and space. He discovered that no matter how fast you chase light, the speed of light in your eyes is always 300,000 kilometers per second, and never slows down. What does that mean? It means time and space are not fixed. They warp and twist as your speed changes. When Einstein wrote this conclusion down on paper, the entire physics community went insane, because it shattered the entire physical edifice Newton had built. Even more terrifying is time dilation. In 1971, two American physicists ran an experiment. They synchronized two atomic clocks perfectly. One stayed on the ground, the other was put on a plane and flown around the Earth. When the plane landed, they were horrified to discover that the clock in the sky was 59 nanoseconds slower than the one on the ground. 59 nanoseconds doesn't sound like much, but it proved a brutal fact: the faster you go, the slower time flows. Scientists calculated that if you sit in a spaceship and fly through the universe at 99% of the speed of light for 1 year, 7 years will have passed on Earth. That means when you return to Earth, your friends, your family, the entire world will be 6 years older than you. You think you just took a trip into space, but time has abandoned you. And when your speed approaches 99.9% of the speed of light, time dilation becomes even more horrifying. You spend 1 year on the ship, and 22 years pass on Earth. At 99.99%, 70 years pass on Earth. At 99.999%, 223 years pass on Earth. You see, the universe is that ruthless. It uses time to completely isolate you from civilization. But that's not even the most desperate part. The real killing blow comes next. Scientists discovered that as an object accelerates, its mass increases. Yes, you heard that right, mass increases. A 1 kilogram iron ball, when flying at 90% of the speed of light, becomes 2.3 kilograms. At 99% of the speed of light, it becomes 7 kilograms. At 99.9%, it becomes 22 kilograms. And as it approaches the speed of light infinitely, its mass tends toward infinity. What does infinity mean? It means that even if you add up all the energy in the entire universe, it still wouldn't be enough to push it even a tiny bit faster. This is the true nature of the light speed shackle. It's not a wall you can break through. It's an absolute prohibition written into the laws of physics themselves. At CERN, there's a 27-kilometer-long Large Hadron Collider built specifically to accelerate protons. They accelerate protons to 99.999991% of the speed of light, consuming as much electricity as a small city uses in an entire year. But even if they poured in 100 times more energy, the proton's speed would only go from 99.999991% to 99.999991%. It's always short by just that tiny bit. In 2011, scientists discovered something even stranger. When protons approach the speed of light, the spacetime around them warps, like a transparent cocoon wrapping around them. Any force that tries to make them go even faster gets absorbed by this spacetime cocoon. It's as if the universe itself is saying, this is as far as you go, no further. So why does the universe set this limit? Scientists have proposed a chilling answer: causality. If an object could exceed the speed of light, in theory it could travel back into the past. Imagine this: you fire a faster-than-light missile, and it hits its target before it's even launched. That means the result appears before the cause, and the entire logical chain collapses instantly. You could go back in time and kill your grandfather. But if your grandfather is dead, you would never be born. Then how did you go back in time to kill him? This paradox would tear the fabric of reality apart. So the speed of light limit may be the universe's final line of defense, to protect causality. Once it's breached, the logic of the entire universe collapses. But something even more hopeless comes next. Even if you really did have a light-speed spaceship, you'd discover that on cosmic scales, the speed of light is as slow as a crawling turtle. The Milky Way is 100,000 light-years in diameter. If you fly a light-speed spaceship from Earth to the edge of the galaxy, it would take 50,000 years. And the human lifespan is only 100 years. You'd die before you even left the solar system. Even if you don't care about time, a light-speed spaceship still wouldn't help you. Because in 1998, scientists discovered that the universe is accelerating in its expansion. Galaxies more than 14 billion light-years away from us are already receding at speeds faster than light. That means even if you set off at the speed of light, you would never catch up to those galaxies. They will forever slip out of your view. Astronomers did the math. At the speed of light, the region of the universe humans can ever reach is only 16 billion light-years. But the radius of the observable universe is 46.5 billion light-years. The remaining 30+ billion light-years are forever out of reach. What does that mean? It means we are permanently trapped in a cosmic prison with a radius of 16 billion light-years. Those more distant galaxies, those more magnificent celestial bodies, we can only look at them forever, but never reach them. The universe is like a gigantic cage. The speed of light limit is the wall, and cosmic expansion is the prison guard. Humanity is a prisoner sentenced to life. Even more brutal is that as the universe's expansion accelerates, this prison is constantly shrinking. Every billion years, a batch of galaxies will permanently slip out of our view due to expansion, never to return. In 100 billion years, apart from the Milky Way and a few nearby galaxies, the entire universe will turn pitch black. Humans at that time, looking up at the sky, will see an empty, barren night. So is there really no way out? Scientists have proposed some theoretical possibilities. The first is wormholes. According to general relativity, space-time can be extremely warped, forming tunnels that connect two distant locations. If we could find or create a wormhole, we could skip the distance in between and arrive instantly at our destination. This doesn't violate the speed of light limit, because you're not moving faster than light through space, you're taking a shortcut. But the problem is that maintaining a wormhole requires negative energy matter, and humanity has never observed negative energy matter to exist. The second possibility is a warp drive. In 1994, physicist Miguel Alcubierre proposed a crazy idea. Shrink space in front of a spaceship and expand space behind it. The ship itself stays inside a motionless bubble. That way, the ship is stationary relative to the space inside the bubble and doesn't violate the speed of light limit. But the bubble itself can move faster than light relative to outside space. It sounds beautiful, but to create this effect would require negative energy equivalent to the mass of Jupiter. Humanity can't even manufacture 1 gram of antimatter right now, let alone Jupiter mass negative energy. So the truth is that the speed of light limit is like an unbreakable curse. The universe, 13.7 billion years ago, wrote this number into the deepest layer of physical law. Any attempt to break it will be mercilessly crushed by the rules of physics. Time will slow down, mass will increase, energy will run out, causality will collapse, and those distant galaxies, those magnificent celestial bodies, will forever exist only within our field of view. We will never truly touch them. That is the most cruel part of the speed of light limit. It doesn't tell you that you're not running fast enough. It tells you that no matter how you run, you will never catch up. But maybe that's the universe's design. It gave us eyes to gaze upon the sea of stars, yet used the speed of light limit to trap us forever in this corner. It showed us infinite possibilities, but used physical law to tell us, just look, don't think too much. Maybe somewhere in the universe, there are higher civilizations that have already broken the speed of light limit, laughing at our ignorance. Or maybe every civilization in the entire universe is trapped by this shackle, all struggling inside the same cage, and the speed of light limit is the eternal curse the Creator set upon all civilizations. At the dawn of creation,